Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder why watching a scary movie can make you jumpy for days? But sometimes, a shocking event in a movie just doesn't get to you the same way. Well, this new study dives deep into why that might be. This research explores how our brains learn to be afraid of things, especially when we're dealing with things like trauma or PTSD. They're looking at a new way of studying fear by using film clips instead of the usual electric shocks. This is pretty cool because it feels more like real life, right? We're not usually zapped with electricity in our daily fears. So the big question here is, can scary movie clips teach our bodies to be afraid in the same way that an electric shock can? And if not, why not? The researchers did 2 experiments to find out. Experiment 1 tried to see what makes fear conditioning stronger. They tested if adding an electric shock alongside a film clip made a bigger difference. They also looked at whether seeing a longer scary movie before the experiment helped, and if using pictures of faces as danger signals was better than using simple shapes. And guess what they found? When they didn't include the electric shock, people didn't seem to learn to be afraid in their bodies. Their skin conductance responses, which are like tiny tells from your nervous system that you are stressed or alert, just didn't show much fear learning. But when a shock was involved, boom, there was clear evidence of fear conditioning. It seems like the film clips alone, even though they're scary, weren't quite enough to get the same physiological reaction. They recruited over 120 participants for this first experiment. They were screened to make sure they didn't have major health issues. Different groups saw different things. Some saw the scary film clips. Some saw a longer scary movie first. Some saw faces as danger cues, and one group got a mild electric shock paired with the film clip. They used the classic fear conditioning setup. Imagine you see a picture of a face. That is your conditioned stimulus or CS. This face is sometimes followed by something scary or unpleasant. That is your unconditioned stimulus or US. After a few pairings, you start to feel jumpy or anxious just when you see the face, even if the scary thing doesn't happen. In this study, the scary thing was either a film clip or an electric shock. They measured how much people's skin conductance changed. The results from experiment 1 were pretty clear. For the most part, people only showed significant fear conditioning those skin conductance responses when an electric shock was involved. The film clips alone didn't seem to do the trick. This was a bit of a surprise and led them to the second experiment. Experiment 2 was designed to figure out why the film clips weren't creating the same fear response as shocks. Maybe people just weren't getting that the film clip was a sign of danger. So they tested a few things. They compared groups who saw just one film clip US or 4 different film clip USS against the group that got the electric shock. They also measured something called US expectancy, basically how much people expected the scary thing to happen after seeing the cue. And here is the kicker: everyone expected the unpleasant, aversive thing to happen at pretty much the same level, regardless of whether it was a film clip or a shock. So it wasn't that people weren't aware the film clip was supposed to be scary. They knew it was coming. Even though people expected the film clips to be unpleasant, their bodies didn't react like they did to the shock. The shock group showed clear differences in skin conductance between the danger cue and the safety cue, meaning they were learning to fear the danger cue. The film clip groups just didn't. Again, the shocks were the only things that really triggered this physiological fear learning. They also looked at stress hormones like cortisol. Interestingly, the group that got the shock showed a bigger increase in cortisol after the experiment compared to the film clip groups. This suggests that the shock stimulus might be creating a more intense physiological stress response. And maybe that intense arousal is what the skin conductance measure is really picking up on. So what is the big story here? The researchers found that while film clips can be unpleasant and participants can expect them to be unpleasant, they don't seem to create the same kind of physiological fear conditioning as electric shocks. This wasn't because people weren't aware that the film clips were supposed to be scary. It seems to be linked to the intensity of the physical arousal triggered by the stimulus. Shocks, being a direct physical threat, likely crank up the body's alarm system more effectively. And this higher arousal is what is needed for skin conductance to show clear fear learning. This is important because it challenges how we might interpret fear conditioning studies, especially those using film clips to model things like PTSD. If the standard measure, skin conductance, isn't picking up on fear learning with film clips, it doesn't mean the learning isn't happening in other ways, like in our thoughts or memories. But it does suggest that if you are looking for physical fear responses, the shock stimulus might be essential. What are the limitations? Well, the study mainly looked at skin conductance. There could be other ways people are learning and responding that this study didn't capture. Also, the film clips were 16 seconds long, maybe shorter. Punchier clips would have a different effect. Future research could explore what exactly drives these physiological arousal responses. Are there other types of unpleasant stimuli that work better than film clips? And how can we better measure fear learning when intense physiological arousal isn't present? This research helps us understand the nuances of how we learn to fear, and it reminds us that sometimes the intensity of the stimulus matters more for our body's immediate reaction than the sheer unpleasantness of it. It's a great step in understanding how to better study fear and trauma, and hopefully find better ways to help people cope. What do you think about these findings? Does it make sense that a shock would create a stronger bodily reaction than a scary movie? Let me know your thoughts in the comments below. And if you found this breakdown helpful, please give this video a thumbs up, subscribe to RUBIN'S Mind Lab for more science insights, and hit that notification bell so you don't miss our next deep dive. Thanks for watching, and I'll see you in the next one.